going to talk about odd and even functions. First, I want to get something out of the way. If you have x to the 7 over x to the 5th, well, by definition, x to the 7th means to multiply x by itself 7 times, and x to the 5th means to multiply x by itself 5 times, and x over x is 1, and x over x is 1, another 1, another 1, another 1. Well, 1 times 1 times 1 times 1 times 1 times x is x squared. Now, why were there 2 x's left over in the numerator? Very simple reason. Because 7 is 2 more than 5. That is, we could have gotten this 2 by doing 7 minus 5. You subtract the exponents. Now let's look at x to the 9 divided by x to the 9. On one hand, it's 1. Divide the same two things, you get 1. On the other hand, it's x to the 9 minus 9, which is x to the 0. X to the 0 is 1. There was nothing special about 9. I could have had 19 instead. And 19 minus 19 is still 0, and x to the 19 over x to the 19 is still 1. That is, x to the 0 is 1. Fair enough, x can be 0. But other than that, x to the 0 is 1. That is, 3 to the 0 is 1. 9 to the 0 is 1. 2/3 to the 0 is 1. 3 to the 0 over 4 to the 0 is 1 over 1, which happens to be 1. Negative 2 to the 0 is 1. 5 times 3 to the 0 is 5 times 1, which is 5. As long as the base is not 0, any non-zero number to the 0 power is 1. There's a reason why we need that, and it will become clear very quickly. Now, the definition of an even function, f, means that f of negative x and f of x are the same. Doesn't matter whether you plug in 5 or negative 5, you're gonna get the same answer. Again, whether you plug in 3 or negative 3, f is gonna put out the same answer. That is, if f of negative 5 equals 11, that implies that f of positive 5 equals 11. If f of positive 7 is negative 4, that implies that f of negative 7 is negative 4. Doesn't matter whether you plug in 7 or negative 7. You're gonna get the same output. This here is the definition of an even function. F of negative x is equal to f of x. Now, what is an odd function? What is an odd function? Oh, an odd function, we also look at f of negative x. F of negative x. This time, we don't get back f of x. We get back negative f of x. So, if it turned out that, so now notice these two differ by signs. If f of negative 3 is equal to 11, then f of 3 will be negative 11. They differ by their sign. Now you may say, well, I wrote this. Well, yeah. I can put the minus, I can multiply both sides of this equation by negative 1, and I'd get negative f of 3 is 11. This and this gave me the same answers. That is, they differ by their sign. If I tell you that f of 5 is equal to 13, then f of negative 5, let's say f of negative 5 equals negative 13. Then f of negative 5 would be the negative of negative 13 or positive 13. These two, if it's an odd function, they differ by their sign. Nobody ever said that f of 5 has to be positive and f of negative 5 has to be negative. Nobody ever said that. Well, interesting thing would be is what can f of 0 equal? Well, let's call it k for a moment. Well then, f of negative 0 should be negative k. No problem there. But f of negative 0 is f of 0. That is, I'm supposed to get back the same answer. So, k must equal to negative k. Well, there's only one number that equals its negative, and that's if k is 0. I mean, you can add k to both sides if you prefer, and then you get 2 times some number is 0. That number is 0. That is, if you're an odd function, f of 0 must be 0. F of 0 must be 0. That is, f of 0 has to be 0. Every odd function, f of 0 has to be 0. Because f of 0 and f of negative 0, on one hand, they must differ by signs. But on the other hand, they have to be equal. The only way k and negative k can be equal is if k is 0. That is, f of 0 must equal 0 if f is odd. That's called the theorem. Now, there are some functions, well-known functions, that are even and odd. For example, the cosine of negative x is equal to cosine of x. It is, it doesn't care whether you plug in x or negative x. If somebody asks you to find on your calculator the cosine of negative 60 degrees, you can save some time and just type in the cosine of 60. Get the same answer. They're equal. Why? Because the cosine function is even. Now, an odd function is the sine of x. The sine of negative x, it doesn't equal the sine of x. It equals negative the sine of x. So, if you need to find the cosine of negative 70 degrees, it's not going to save you any time, but you can find negative the sine of 70 degrees. Hey, you know, when might I use this one? Well, if in an earlier problem, and I'm sure I'm going to write down the wrong answer, but suppose in an earlier problem you found out the sine of 70 is 0.834. Okay, so the sine of negative 70 will just be negative 0.834. There's no extra work. You don't have to type this or that into your calculator. Now, of course, I suspect that number is wrong. But you get my point. If you already calculated the sine of 70 degrees for an earlier problem, well then the sine of negative 70 will just be minus what you got earlier. It will be negative the sine of 70 degrees. You don't have to keep inventing the wheel. Don't have to keep typing the same problem. Now, suppose that you have that f of x is 7x to the fifth minus 3x cubed plus 11x minus 13. The problem is this even or odd? Well, there's a couple of things you need to know. First of all, if all the exponents on x are odd in a polynomial, then it's an odd function. And if in a polynomial all the exponents are even, then it's an even function. If they have both odd and even, then it is neither. What you need to realize is that there's a 1 here, and that 13 is the same as 13 times 1, where I write 1 is x to the 0. This is still 13. And what happens here is not all the exponents have the same parity. They aren't all even, nor are they all odd. This function is neither odd or even. And basically, if you were to compute f of negative x, you'd have 7 times negative x to the fifth minus 3 times negative x cubed plus 11 times negative x minus 13. And this will give you negative 7x to the fifth plus 3x cubed minus 11x minus 13. Now, this is not f of x, and it is not even negative f of x, because if I factor out a minus sign, I get minus 7x to the fifth minus 3x cubed plus 11x plus 13. What's in here is not f of x because of that plus 13. So it is not negative f of x. It's neither. If you have this function, f of x is equal to 3x to the sixth minus 21x squared plus 13, this function is even. And the reason is that, well, for one thing, 13 is x to the 0, and all the exponents are even. 6 is 2 times 3, 2 is 2 times 1, and 0, of course, is 2 times 0. All the exponents are on the 2 table. They are even. And if you wanted to, you can verify it Yes, 3 times negative x to the 6 minus 21 times negative x squared plus 13. Well, a negative times itself 6 times is positive, and x to the 6th is x to the 6th, minus 21, negative x times negative x, well, negative times negative is positive, times x is just x squared, plus 13. Oh, that's exactly f of x. F of negative x is equal to f of x. So yes, it is an even function. If you have a polynomial and all the powers of x, or whatever the variable is, x, y, z, if they are all even, then it's an even function. They're all odd, then it's an odd function. If I tell you that g of y is equal to 7y to the 5th minus 3y to the 7th plus 13y, this is an odd function. First, recognize that y is the same as y to the 1. And it's an odd function because all the exponents are odd. And what happens with an odd function is if you replace y with negative y, you're gonna be able to factor out a minus sign. Negative to itself 5 times is negative, times 7 times y to the 5th, minus. Negative times itself 7 times is a negative, which will make that positive, times the 3 times y to the 7th. A positive times a negative is a negative. Well, what I have here, if I factor out a negative sign, is negative, and what's in the bracket is g of y. It's exactly g of y. And if g of negative y equals negative g of y, then g is an odd function. Now, what if we have a rational expression? Rational expression is the division of two polynomials. Suppose I tell you h of x is 3x cubed minus 4x all over 7x to the 5th minus 3x. Now, all the exponents are odd. There's understood ones here. The exponents of x are 1, 3, and 5. Actually, the first 3 odd numbers. So you may think, well, this is obviously odd. No, it isn't. Because when you plug in negative x for x in the numerator, you're going to be able to factor out a minus sign. And in the denominator, you're going to be able to factor out a minus sign. And those two negative signs will cancel out. For the numerator, we have negative 3x cubed plus 4x. In the bottom, we have negative 7x to the 5th plus 3x. Now, what we have here, it doesn't look like h of x, it doesn't look like negative h of x, but if I factor out a minus from the numerator, I'll have 3x cubed minus 4x after the minus sign. And if I factor out a minus sign in the bottom, I'll have 7x to the 5th minus 3x. Well, these negative signs cancel out, and we have 3x cubed minus 4x over 7x to the 5th minus 3x. But that's exactly h of x. So, since h of negative x is equal to h of x, this is an even function. Okay, h of x is an even function. This pattern works out as follows. If you have an odd function divided by an odd function, think of positive as even and think of negative as odd. So you have a negative over a negative, which is a positive, which is even. If you have an even function divided by an even function, positive over positive is positive, which is even. If you have an odd function divided by an even function, you can think of odd being negative and even being positive, and you get negative, but negative is odd. Okay, I mean, this here is gibberish, but it works. This is complete gibberish, but it works. Odd over odd is even. That makes sense. Even over even is even. Odd over even is odd. But it's a coincidence that if we assume that even is positive and odd is negative, that we get the same answers that we should be getting. Even over odd. Think of even as positive, odd as negative. You divide a positive by a negative, you get a negative, and negative means odd. That is, an even function divided by an odd function turns out to be odd. It's called magic. It just happens to be that way. Now, let us talk about how, in knowing that a function is even, can tell us how to graph literally half the graph. If I were to tell you that for x being positive, the function f of x goes like that. Well, when you plug in negative x, you get the same y values as when you plugged in positive x. You're going to get that. In other words, if you plugged in that x value, it told you to go up that height. Well, if you plugged in the mirror image, instead of this x value here, you plugged in negative x, you're supposed to get the same height. That's what an even function tells you. For this x value, I'm supposed to go up to that height. Well, for the same negative value, I'm also supposed to go up to the same height. Fine, it doesn't look like I did that, but I drew this freehand. But it's supposed to be the mirror image across the y-axis. So if you know half the graph, whether it's the blue half or the yellow half, you then know the other half, if f of x is even. Now, what happens if f of x is an odd function? And suppose that you know that it goes like this. Now, let me draw this more horizontally. Suppose you know it goes like this. And this is the graph of f of x. And it is an odd function. Well, for 0, Okay, so actually this cannot be an odd function, but this can. Because remember, to be an odd function, you have to be 0. And basically, it's symmetrical across the origin. The other half goes like that. In other words, for this x value, it says go up that amount. Well, for the same negative x value, that is, if this were 2, I'm talking about negative 2. Instead of going up that amount, you go down that amount. And I'm not saying that when x is bigger than 0, you always have to be positive. Whether you're positive or negative, on the other half of the y-axis, it's going to change signs. For this x value, it says go up that amount. For the same value but negative, it's going to say go down that amount. Okay, now, you could have, in theory, plotted the green part first, and then the yellow part comes for free. Or, you could have plotted the yellow part first, and the green came for free. Or, you could have plotted the yellow and green, and then verified that, yep, that's an odd function. Okay, that's the graph of an odd function. If it wasn't a graph of an odd function, then I would suggest that you go and find your error. Now, another way of graphing this is it has 2 reflections. An odd function, it has 2 reflections. One across the y-axis and one across the x-axis. Which one you do first, that's up to you. But it has 2, it can be realized from 2 reflections. First, if I reflect this graph across the y-axis, I would get something that I would be comfortable in saying it's that. And then this green function, I reflect across the x-axis. And what I would get is something like that. Okay? Now this green part is gone. It helped me, but it was gone. It's gone now. That there is a graph of an odd function. That is the graph of an odd function. If instead I took the yellow and I reflected it first across the x-axis, fine. Now I take this reflection across the x-axis and I reflect it across the y-axis, and I get that. However you do it, you get the blue. Now this pink is not part of the graph. This pink is not part of the graph. This here is the graph of an odd function. And I would give students part of the graph, and I asked them to draw the rest. In other words, I would give them, say, that blue piece and this yellow piece. That's all I give them. And I say, graph it. So, if you have this, then you have to have that. And if you have to have this, then you have to have that. And that would be what I would expect them to give me. So again, if you're only given this piece and this piece, you should be able to come up with those two pieces knowing that the graph is odd. Knowing that the graph is odd. And now, I'm going to give you a graph, and we'll see what we can do. Suppose that this graph is even, and I tell you it goes like this. That's up to 2. And then at negative 2, it goes like that to 7. Well, an even function is the reflection across the y-axis. Well, and here is the y-axis. If I reflect this across the y-axis, I'm going to get that. And if I reflect this across the y-axis, I'm going to get that. I'm going to get this. And there's the graph. Just given what's in yellow and told that it's an even function, you should be able to come up with the blue piece. So in all, the graph is just that. And of course, this should be 7, and that of course should have been negative 7. And that is the graph of, say, g of x. And all you were given was part of it. You were given this piece, say, and that piece. And all you were told is that it's an even function. Finish the graph. Okay. Now, of course, it could have went like that at the end. We don't know that. And if you drew that, it wouldn't be marked wrong. But you definitely have to know to add on this piece and to add on this piece. Anything else you add on, like this piece here and this piece here, that's up to you. Just make sure you're not making a mistake by doing more than you have to. This completes the video on odd and even functions.